So this course is about introduction for computer-aided design or CAD. So we'll go from very basics till advanced topics of how to use computer software to design 2D and 3D models. So in computer-aided design or CAD, 2D basically refers to two-dimensional drawings or representations. So CAD software is typically used by engineers, architects, and designers to create detailed drawings of objects and structures. So in a CAD environment, the 2D drawings are typically created in flat plane, that is a two-dimensional plane, as we can say, and they represent the length and width of the objects. So, but not its depth. So that's why we call it two-dimensional, that is length and width. So in a 2D CAD drawing, you can create geometric shapes like lines, arcs, text, everything, which are components of any object with various elements of the design. And these drawings are often used to create floor plans or schematics and other technical illustrations. So while 2D is very important and valuable for certain applications, so modern CAD software tools often includes 3D capabilities, allowing the designers to create also three-dimensional objects for creating the objects. So in summary, basically 2D it refers to the two-dimensional, which is the length and the width of the object. So as you see here, I have put the x and y axis, where you see x is phi and y is phi. So the point I'm referring to is phi comma phi. So in a two-dimensional, we have length and width, and 2D shapes are basically drawn on a flat plane. So that is the basic about two-dimensional. Basically, it's nothing but a flat plane where you have length and width. So that's the basic concept of two-dimensional. So in as I just told you about 2D, now we go to 3D. 3D is three-dimensional, basically length, width, and also depth. So that's why we call it three-dimensional, which represents the real-time object. So we have two eyes and we see 3D objects. So to represent that, we have three dimensions. So that's why we call it which is with three dimensions. So in 3D, CAD designers or computer-aided designers can create virtual representation of physical objects, and for buildings or products or any objects with realistic depth perspective and spatial relationships. So this provides a more comprehensive and accurate view of the design compared to 2D. 2D you'll just see one view of the object. In 3D you can have two views. So if we and 3D CAD models are basically useful in engineering, architecture, and when you are doing a product design. So some of the main features of 3D, which includes is like spatial representation. That is, it allows for creation objects in three-dimensional space and enabling designers to visualize the object as if you see the real object. And visualization, designers can view and manipulate the 3D models in different angles to see the different perspectives, like for example top view, side view, bottom view, and different kinds of views. And assembly modeling, designers can create assemblies of parts, allowing them to see individual components, how they come together to complete a product. So different parts, how they fit in together. And concept of rendering, which includes 3D software. Many 3D softwares use the rendering capabilities, allowing the designers to create realistic images of model objects with lighting, textures, and shadows. So these features is what is called rendering and simulation. And 3D software also offers simulation tools to analyze the structures and behavior in various conditions such as stress, heat, and flow. That's why we do the process simulation. So basically 3D enhances the design process for a accurate creation of any product. And in this picture you can basically see the 3D, that is three dimension, x, y, and x, z axis, where you have one point, say phi comma phi comma phi. So it has three dimensions in this object, and this is what basically is a three-dimensional object and three-dimensional concept in computer design. So in this diagram you see some example, square and a rectangle. A square in 2D will be a cube, that is it adds one more dimension as you see, and a rectangle becomes a cuboid which adds one more dimension. So that's about this basic shape. And in this example you see far more two examples of 2D and 3D shapes. For example, a square, if it's projected to a 3D, it will be a sphere. A semicircle will be a hemisphere, and triangle will be a cone sort of, and a square will be a cube. A rectangle will be a cuboid. So similar thing. So whatever adds one more dimension, that is z-axis, that becomes a 3D object. So coming to basics of CAD, basically previously in initial times when we did not have computers, so people used to design products with paper and pen, and just it will be mostly 3D objects, or they would make real shapes as a simulation. So the computer did, once computers came in, then everything was done in computers. So we have softwares to do that, like Tinkercad, Onshape, or FreeCAD, or take any other CAD software. So to design this, we nowadays use two-dimensional and three-dimensional shapes in CAD software. And this is basically used to design any object like chair, table, or aircraft, or you take any physical object, computer aided design is used. And the advantage is it's low cost production, that is it's digital, and the digital copies can be shared over network to different people, and they can edit the object. For example, FreeCAD is a standalone software, but if you're using a web-based software like Tinkercad or Onshape, or Tinkercad is just for amateurs, but OnCAD or any other which is more web-based. So this many people can work simultaneously on the same object, and it comes to faster production and low wastage. So everything can be simulated in computers, so that when once you make a final product, it is close to accurate, so you don't have to make large production or large samples, which will be a wastage. And it's easy to simulate and identify the problems earlier. So in design you can identify problems which can come, these problems can be identified earlier, defects can be identified in the software stage itself, so that the production, when once it goes to production, the materials can be saved, the large defects can be fixed. So earlier we identify the defects, it's more cheaper, or we save a lot of money and time. So that's some of the basics of CAD and its advantages. Some basic software CAD tools is, as I said, Tinkercad is amateurs. You can still design a lot of things with it, which comes from Autodesk. FreeCAD is a free software. You can just download it and start doing it for student projects or any other. But Fusion 360 is there from Autodesk. Onshape, SolidWorks, CATIA. These are some. Onshape is from PTC, and these are all some of the CAD software which is typically used in the industry. So this course is all about FreeCAD. So we have covered some basics of CAD. So FreeCAD is began in 2001, the development by Jürgen Riegel, and this FreeCAD is a general purpose software, a parametric 3D modeler, which is licensed under LGPL license. And FreeCAD is aimed directly at mechanical engineering and product design, but it's very generic. And this is a freely downloadable software, and you can use it for any of your professional or learning purposes. So here we'll see the FreeCAD front end, how it's divided. So the number one will be the main view area, which contains different tabbed windows, principally all the 3D view, all the objects which can be shown here. Number two is the 3D view, that is showing the geometrical objects in the document. And number three will be the tree view, where tree view or part of the combo view, which shows the hierarchy and the construction and the history of objects in the document. It can also display the task panel for active commands, so that is the tree view. And number four is the property editor, where you can edit the properties of each of the objects you select in the number three. And This allows the modifying the properties. And number 5 will be the selection view, which indicates the objects or the sub elements of the objects, just the vertices, edges, faces that are selected. And number 6 is the report view, or the output window, where messages, warnings, and the display, whatever happens to your input, the output is shown here. Number 7 is the Python console, where all the commands are executed and are printed, where you can enter Python code here, sort of a Python console. Number 8 will be the status bar, where some messages and tooltips appear about the status of the software. And number 9 will be the toolbar area, where the toolbars or dock which can be used to for your 3D models. Number 10 is the workbench editor, where you can select different kinds of workbenches like part design or architecture or anything else. And number 11 is the standard menu, which holds all the basic operations on the top. So this is the basic front end view of FreeCAD. These are the sections which is described from the FreeCAD website itself. So let's go on to the next step of how to make things.